Right, this last example, example 4, there was a little bit of an error during my last record, so um, I'll just walk through it after the fact. So a little bit different than the previous videos, but all is well. So first thing we want to do is notice that these two, they're functions of y, so we can set them equal to x. And then each of these then we can interpret as some sort of parabola that either opens a left or opens right. So a parabola that's a function of y would open right when the leading coefficient, so the coefficient of the highest degree, so the quadratic term, is positive. So this is a positive coefficient, so it will open in the direction of positive x, so rightward. And then this coefficient is negative, so it will open left. Once you know whether a parabola opens, once you know the direction of the opening of the parabola, you then really, if it's easy, find the intercepts. Then you can just connect the dots and draw a nice U or parabolic shape through them. So we can factor this to find the intercepts. So this one factors into y times y minus 4. So the intercepts are 0 and 4. And it opens rightward, so we can just draw a nice little parabola through it. Similarly, for the parabola that opens to the left, intercepts are y equals 0 and y equals 2. So 0 and 2, and then we can just connect it with a nice little parabola. So the region whose area we're trying to determine is this little shape here. So we can actually further just kind of shade that. So our region, the left boundary, is y squared minus 4y, and the right boundary is x equals 2y minus y squared. So we do need to figure out what this value is, because we do know that we're going to integrate from 0 to something, and that something is whatever this y value is right here. So to find the intersection, we can set the two boundary curves equal to one another and solve. Moving everything to one side, everything moves to the right in this case, I decided. We can then factor and solve to get 0 and 3. So this y-intercept here is actually 3. Okay, so then we set up our area integral. So we have the integral from 0 to 3. And we'll have our top function minus our bottom, or sorry, not top and bottom, excuse me. I meant to say right function minus our left function. So distribute, collect like terms. Then we can integrate using the power rule. And then if we plug in 3 and simplify, we get 9.